Hi guys, welcome back. For this video, I will go through some of the assignments. Let's start with number one. The first one is we have a table over here and we need to find the expected number of successful site visit sales pitches per day. If we want to find expected number of success, we need to use success multiplied by probability. So we're gonna use every successes level multiplied by probability over here. So we're gonna get 0 times 0.1 plus 1 times 0.3 plus 2 times 0.3 plus 3 times 0.2 plus 4 times 0.1. We're gonna get successes of each level. We get 0 plus 0.3 plus 0.6 plus 0.6 plus 0.4, which is equal to 1.9. And then we will move on to the next one. Based on a poll, 67% of internet users are more careful about personal information when using a public Wi-Fi hotspot. What is the probability that among 3 randomly selected internet users, at least one is more careful about personal information when using a public Wi-Fi hotspot? So, we know that 67% of internet users are careful, and we have 3 samples over here. We need to find at least one is careful. So at least one and one person is careful is not the same. They're different. At least one can be one or two or all of them. But one user is one user. So if we want to find at least one, we need to find 3 things. First, the probability of one person is careful. So P of 1 is careful, which is we already know is 67%. The next one is P of 1 is not careful. So we will use 100% subtract by 67%, which is the careful one. So we will get 33%. It's a probability that one is not careful. So after that, what is the opposite of at least one? As I said, at least one can be one or two or all. So the opposite is all of them are not careful. So to find all of them, we need to use 33%, which is 0.33 powered by 3, because we have 3 people as a sample. So we will get 0.037 or 3.7% is a probability that all of them are not careful. So now we can find at least one is careful by use 100%, subtract by 3.7%, and we will get 96.3%. So 96.3% is a probability of at least one is careful. So the answer is 96.3%. So let's move on to the next one. In a genetics experiment on peas, one sample of offspring contained 373 green peas and 275 yellow peas. Based on those results, estimate the probability of getting an offspring pea that is green. So to get a probability of offspring that is green is use green divided by the total offspring, which is n. So the green is 373 and the n is 373 plus 275, which is green and yellow combined together. So it's equal to 0.57562. So if we convert it into the percentage, it's gonna be 57.562%. So the answer is 57.562%. The next question is this probability reasonably close to 3.3 over 4? 3 over 4 is 75%. So the correct answer is no. It is not reasonably close because the probability is 57.562%. Let's move on to the next one. Two fan coins are tossed and the events given below are defined. Event A is observe at least one head. Event B is observe exactly one head. So the A part is to draw a Venn diagram. A Venn diagram, as we learned, is the two circles in one square. So you gotta ask yourself that event A or B, which one is bigger? Obviously, event A is bigger. So the answer is A. So to find the probability of P of A and P of B and P intersect B, you have to write the sample space of the experiment first. So two fan coins are tossed, we can get head, 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 toe, toe, head, and toe, toe. So the P of A is at least one head. This means here, here, and here. So we get 3 out of 4. And event B is exactly one head. We can get over here, over here. So it's 50% 2 over 4 or 1 over 2. We're gonna do it 1 over 2. And then A intersects B. As you can see on the Venn diagram, A and B intersect is shaded area or B. So it's gonna be 1 over 2 also. And then part C is to use a formula of conditional probability to find P of A given B and B given A. So as we learned from last video, the formula of P of A given B or P of B given A is going to be like this. P of A given B is equal to P of A intersects B divided by P of B, and P of B given A will equal to P of A intersect B divided by P of A. So this will equal to 1 over 2 divided by 1 over 2, which is equal to 1. And then second part is P of B given A. We're gonna have 1 over 2 divided by 3 over 4 from P of A and P intersect B. This will equal to 1 over 2 times 4 over 3. So we get 2 over 3. So let's move to the last one. The last one is compute each of the following by using combination rules. So as we learned from last video, combination rule is to draw something out of something. So it's gonna be big N factorial divided by small n factorial times big N minus small n factorial. So in this question, we're gonna compute all of these four. Let's start with the first one, is 6 and 5. So it means that 6 factorial divided by 5 factorial times 6 minus 5 factorial. To do it, we can do it like this. It means 6 times 5 times 4 times 3 times 2 times 1. All divided by 5 times 4 times 3 times 2 times 1 times 1. Because 6 minus 5 factorial is 1 factorial equal to 1. So we can eliminate this and this. So we will get 6 over 1 equal to 6. So the first answer is 6. The next one is 9 and 3 is equal to 9 factorial divided by 3 factorial and 6 factorial, which is from 9 minus 3 factorial. We can do it fast by uses like this. It's equal to 9 times 8 times 7 divided by 3 times 2 times 1 equal to 3 times 4 times 7 will equal to 84. So it's 84. And part C, if you see like this, you can answer 1. You cannot have a different samples because you pick it all. Okay, and then part D is 5 and 0. So it's gonna be 0. So it means none of them are to be drawn from the set of 5. So it's going to be 0. So that pretty much it, guys. I will see you in the next video.